this example, we're going to look at an application problem and see how we can use the commutative property of addition to make the problem more simple. So let's look at the problem. Raj recorded his weekly expenditures and deposits in a notebook. He wrote down the following expression to represent his current balance. 1,230 minus 50 minus 20 minus 8 plus 120 minus 72 minus 160 plus 340. Find the balance in Raj's account. Well, this is a lot of computing to do. So, officially, this is all addition and subtraction, so we said that we're going to compute these from left to right. So I'm going to use the calculator here. 1230 minus 50 gives us 1180, minus 20 is 1160, minus 8 is 1152, plus 120 is 1272, minus 72 is 1200, minus 160 is 1040, plus 340 is 1380. So the balance in Raj's account is $1,380. Now notice if we had computed that by hand, that would have been slightly painful, even for me, and I like doing math problems. So we would have had to compute this result, then subtract, then add, then subtract, then add. So working from left to right made this a little bit more complicated than it needs to be. But since there's subtraction and addition, we have no choice but to work from left to right. So now we're going to rewrite this expression using only addition. So we learned that we can rewrite subtraction as the addition of the opposite of a number. So 1230 plus negative 50 plus negative 20 plus negative 8 plus 120 plus negative 72 plus negative 160 plus 340. So now we've written the expression using only addition, and we're going to see in the next slide why this is going to be incredibly useful. So here's a copy of the result from Part B, and now we're going to use this result to complete the table below. So we can tell that any positive number can be thought of, the 1230 can be thought of as Raj's initial balance, and we'll put that under deposits because it's positive. And any negative number can be thought of as a withdrawal. So I'm going to put 50 in the withdrawals column. Okay. Continuing in this way, we have 20 in the withdrawals, 8, then 120 in deposits because that's positive, 72 in withdrawals because that's negative, 160 in withdrawals because that's negative, and 340 in deposits. So now we're going to find the totals, the sums, of all of his deposits and all of his withdrawals. So adding the deposits, I don't even mind doing this without the calculator. We have 0 in the ones place, 7, 80, 90, 300, 400, 500, 600. So 1,690 is the deposits. Now let's look at the withdrawals. 8 and 2 is 10, so 0, carry the 1. 5, 6, 7, 8 and 7 is 15, and 6 is 21. Carry the 2, and 2 and 1 is 3. So he made $310 in withdrawals. Now we can use this information to find Raj's balance. So this original statement is equivalent to 1690 plus negative 310. Okay, since the signs are different, we're basically subtracting and keeping the sign of the larger number. So the larger number is 1690. The smaller number in absolute value is 310. I'm just going to hop to the calculator for this. 1690 minus 310 gives us 1380. And our result is positive. So that's Raj's balance, and that's consistent with what we found below. So please note why this was incredibly useful is once we had changed this problem all to addition, it didn't matter which numbers we added together first. We just took the positive numbers and added them here, and we took the negative numbers and added them in the withdrawals column. We didn't work from left to right, and we didn't need to because of the commutative property of addition. It says that we can reverse or interchange the order of any two numbers, which means we can interchange the order of all of the numbers any way we wish once we've changed it to addition. So this made the problem a lot simpler.